Today we'll be talking about conditional statements. Now, conditional statements, that's in logic and reasoning is in geometry. Now, conditional statements are all statements that are in the form if A, then B. And all this if A, then B thing means is that if a condition is met, then the action can be performed. Hey, I just used a conditional statement. Okay, anyways, now let's give you a couple more examples about what this if A, then B thing, what that really means. So, as my mom always said, if I finish my homework early, if I finish my homework early, then I get to play video games. But, okay, it's probably true, but is this true or is this false? And how do we prove that a conditional statement is true? Well, we have to give no counterexamples, and a counterexample is basically just an exception to our conditional statement. And to prove that one is false, we just do the opposite thing. We have to give one or more counterexamples. One is enough, but even more is way better. And again, counterexample, that's an exception. So here, if I finish my homework, then I get to play video games. Well, every time I do finish my homework early, I do get to play video games because my mom always keeps her promise. So that means there's 0 exceptions. So that means this is a happy and true conditional statement. Okay, now let's give you a little more formal math explanation for a conditional statement. For conditional statements, that is. So say I have if angle A and angle B are congruent. So say we stick if angle A and angle B are congruent, then we have to stick in something for B. We can't just leave B alone. So B, let's see, okay. Then we have angle A and angle B have the same degrees measure. D-G-R-E-E-S, degrees measure. So there's our conditional statement. Well, is this true or false? You gotta prove if it's true or false. Well, since angle A and angle B, they're the same, exact same things, that means they do have the same degrees measure. Not very convincing maybe, but at least we know that this is true. It's a true conditional statement. Now let's look at another example, our last and final example for what a conditional statement is. So say that if I smile, then a dog will come. Well, if I smile, the dog almost never comes. So that means our conditional statement, I should say, is false. Now, after we reviewed all this, not exactly review, after we talked about all this and conditional statements and what they are and examples, what does this A and B really mean, or really mathematical meaning? Well, our A for if A or A is basically our hypotheses, because, well, the A doesn't have to happen because if A, then B, well, the B, that's our conclusion. That means if the A happens, then this will happen. Whatever, that means we can conclude something. But our conclusion, it can be true or false, and if our conclusion, if it's true, that means the whole statement is true, or if it's false, then the whole statement is false. Meaning that, again, conditional statements is true or is false. Now let's look at the converse of a conditional statement. The converse is just converse. So the converse is, well, Converse is basically the opposite of a conditional statement. We basically flip these around. If B, then A. In a conditional statement, that's very similar to a conditional statement. It can be true or it can be false. Now, say me take the converse of if angle A and B are congruent, then angle A and angle B have the same degrees measure. Well, what we do is that we just flip B and A around. We flip AB around, then we get if angle A and angle B have the same degrees measure, then angle A and angle B are congruent. Now, we gotta prove that if this is true or false, and it's the same thing. We have to give, and to prove that one is false, we have to give one or more counterexamples, and to prove that one is true, we have to make sure that we have no counterexamples, or you could say it works in all conclusions and conditions. Well, since they have the same degrees measure, if angle A and angle B have the same degrees measure, that means they're the same, also meaning that they're congruent. So then we see the converse of angle A and angle B is also true. I mean the converse of this conditional statement is also true. But what about untrue statements? Let's see, put a little bar here. This one should be good. So say I have the conditional statement if x is 4, x equals 4, that's our A, we've taken that for A. Then, let's see, x cubed has to equal 64 because 4 cubed, that's 64. Now here's our problem. We want to take the converse of this conditional statement and then determine if it's either true or if it's false. Now let's see. We just say this is our A, this is our B. We just flip these around, then we get if x cubed is 64, then x equals 4. X equals 4. And now we see there is no counterexample for this converse of a conditional statement. For this converse, because when negative 4 doesn't work, there's probably no square roots or anything. So that means you can find 0 exceptions or counter examples. That means the converse of this conditional statement is also true. But what about conditional statements what about converses that aren't true? So far we've just been talking about true converses. What about non-true? Okay, first, I gotta look at this carefully. I'm about to erase it. Got it? Okay, good. Let's see. We'll take a look at another conditional statement. So say if our A this time will be if A equals 2, then A to the 4th has to equal 16. And then again we want to take the converse of this conditional statement and then determine if it's true or false. Well, first, this is our A, that's our B. We just flip these around and then we get if A to the 4th equals 16, then A equals 2. We just take the converse. Then A equals 2. Well, how do we prove that this is true? Well, we see that, how do we prove that this is false? Well, we see that there is a counterexample because we can also say that A equals It can be 2, but it can also be -2, since -2 to the 4th power, that is 16, meaning that this converse is false.